Hello everyone, welcome to Chorus Camp. So today we are going to cover the second part of our recursion series. In our previous video, we have seen what is recursion, how does recursion work, what is the base condition, what is the recurrence relation, and today we are going to cover the first recursion problem using the previous techniques we have learned. So let's get into the problem statement first. After the introduction video, the first recursive problem we are going to see is search a 2D matrix. If you want to see the iterative approach, you can check the link in my description. So here the problem statement says an efficient algorithm that searches for a value in M cross N matrix, integer in each row are sorted from left to right, and the first integer of each row is greater than the last integer of the previous row. So here we are given with a sorted matrix and we have to return true or false if we find the target. Before getting into actually how we are applying recursion in this problem, let's understand the logic a bit and then move on to our coding part. So here, since our array or the 2D matrix is sorted from left to right and top to bottom, we are going to start our iteration here in the bottom left corner of the matrix because this is the point where the value starts increasing towards right and decreasing towards upward direction. So our target here is to find 5. What are we going to do? We are going to check if this is our target. If it is not the target, then we are going to check whether our target is less than this value or greater than this value. If our target is greater than this value, then we are going to move our search towards right because the value starts increasing towards right. And if this value is less than this value, then we are going to start searching or move our pointer towards upward direction. So let's start searching of 5 starting from position 18. So here 18 is not equal to 5 and we are checking whether 5 is less than or greater than 18. 5 is actually less than 18, so we are moving our pointer upward. So now we are here at 10. Whether 10 is equal to 5? No. And whether 10 is less than 5 or greater than 5? 10 is clearly greater than 5. 5 is less than 10. So we are moving again to upward direction. So we moved upward to 3. Now 3 is actually less than 5. So it's time to move towards right since the greater values are towards right. So we are moving our pointer to 6. 6 is actually greater than 5. So time to move up. So we are moving to 5. We reached our target. So we are going to return true. This is how we are going to use an efficient search algorithm to search our target. So we know how the iterative solution works. Now, since it is a part of recursion series, I'm gonna let you all know how we are going to code it in recursive way. So here we're gonna get the help of a helper method. So let's write, it's gonna return Boolean values. So we are getting the input of our matrix and a target and the index of each cell, that is row comma column or I comma j, any variable to indicate the index of each cell. So let's have it I comma j. So now, as I said, we're gonna find the recurrence relationship between each subproblem. As we understood the problem statement, every time we are going to check if the value at the index I comma j is equal to our target. If then, we are going to return true. So I'm going to write if matrix of I comma j is equal to target, then return true. This is the operation we're going to perform. If not, if it is not equal to the target, we are going to check if our target is less than or greater than the value at the matrix. If it is greater, move up. If it is less than, move right. So every time we clearly know, since recursion uses a call stack, looping is not allowed inside recursion. It is not allowed. It will help you to not run your recursive program in infinite loop. So I'm going to return. In return, I'm going to check a conditional loop, that is if my matrix value is less than my target, then I'm going to call the same helper method, which is going to pass our matrix target. And as we know, if our target is less than our matrix value, which means we have to move upwards. So upwards means one row before the current row, so which means I minus 1 comma j. If not, if it is greater than the matrix value, then call the helper method, which pass our matrix target and a same row but one column next to the row, so which means j plus 1. So here we simply found a recurrence relation that checks whether our value is less than target or greater than target. So according to that result, we're gonna call our helper method and shift our searching direction towards upward and right. So every time it encounters a new value, it is gonna call the same methods again and again based on the value given. And finally, if it matches, then it is gonna return true. If not, we have to return false. So where do we return false here? So we are missing one thing here, that is we need to stop our methods to calling itself, because every time it finds its value, it is gonna keep calling the method again and again. So to do that, we need our base condition. So here our base condition is, since it is a matrix, our rows and columns cannot go beyond limits. So we are going to check whether our rows and columns are within limits, or if it crosses the limits, then with that case we did not find our target value in the given matrix, so it is time to return false. So we are checking every time that if our row is less than 0 or column is less than 0, or a row goes more than the number of rows present, or our columns are greater than the number of columns given. That is the case, we did not find a value, so return false. So yes, we put our base condition, we found a recurrence relation and called the matrix, and finally our code that checks whether it matches the target value, then return true. So let's call our method from our main method. So we are going to return the method, pass our matrix target, and as I said, we are going to start from the bottom left cell. So our bottom left cell will be at last row first column. So last row first column will start at 0th index. Let's run. Yes. Yes, the solution is accepted, and that is the fastest solution that runs in 0 millisecond. So here in our first video, we understood what is a recurrence relationship and a base condition. By using that, we approached a problem simply using our recursion technique and solved it. So let's wait for more videos we do on recursion and solve problems using recursion technique. If you like the video, hit like and subscribe. Thanks for watching. Thank you.